corporate server is being drained of its proprietary data in milliseconds. There is no malware, no firewall was exploited. Not a single line of malicious code was written to execute this attack. The network was not breached from the outside. The system's own trusted AI assistant was simply talked into opening the door and handing over the data. This is a zero-click language attack. Hackers are bypassing complex exploit kits, using weaponized plain English to hijack the AI agents we have integrated into our workstations. By connecting AI directly to our system privileges and network protocols before we understood how to isolate them, we turned our own productivity tools into a primary vulnerability. The industry recently hit what NVIDIA CEO Jensen Huang calls the inference turning point. We have moved past training models to generate text, shifting toward a landscape where AI is deployed to take autonomous digital action. Agentic AI sits at the center of the workspace, capable of controlling the desktop, reading emails, and executing files. The pioneer is an open-source agent called OpenClaw. In weeks, it was deployed on millions of machines, granted deep privileges to run complex workflows. By prioritizing autonomy for the sake of utility, we have effectively automated the very systems an attacker needs to control to compromise a network. Early attempts to secure agents relied on in-process guardrails, assuming the AI can police its own behavior. But if an AI reasons, it can be reasoned with. Attackers can prompt the agent to ignore safety protocols. Add in massive third-party plugin ecosystems, like OpenClaw's Claw Hub, where users download thousands of unvetted tools, and the risk multiplies. The agent connects to external resources it was designed to trust. An artificial intelligence cannot act as its own uncompromisable security guard when its core design is to follow instructions from the user or an attacker posing as one. Look at how this works in a standard workflow. You ask your AI agent to summarize an incoming email. On the left is the email you see. On the right is the raw code the AI sees. Hidden inside that text is an invisible instruction, an indirect prompt injection, telling the agent to stop its current task and secretly forward sensitive files to an external server. The AI processes this hidden language, leveraging high-level privileges to execute the attack. You never clicked a malicious link. The agent followed an invisible command. Once that first agent is compromised, it can use its network access to trigger and infect other subagents across the enterprise network. The technical barrier has completely changed. Attackers no longer write complex code. They achieve goals using weaponized English. The industry is now pivoting away from behavioral trust. We see this with NVIDIA's launch of NemoClaw and its underlying runtime environment, OpenShell. OpenShell introduces out-of-process enforcement. Security rules are moved outside the AI's reach, hard-coded into the host infrastructure. This structural sandbox monitors the network at the binary level. If the agent attempts an unauthorized transfer, the sandbox acts as a physical barrier, instantly blocking the data. Securing a machine that can reason requires moving the control point to the infrastructure itself, creating a boundary that exists independent of the agent's logic. We are approaching a landscape defined by AI factories, data centers housing thousands of autonomous agents, interacting and triggering each other continuously at machine speed. As these agentic systems scale, human oversight is removed from the loop. When agents operate faster than we can monitor them, structural security becomes the only line of defense against systemic failure. We have successfully engineered digital autonomy. The challenge now is building the architecture to govern it.